Hi everyone, in this lesson we're looking at trigonometric ratios in the unit circle. And before you watch this video, I would suggest that you watch my video on memorizing the unit circle. It's about 3 minutes and it'll go into all the details of the entire unit circle and how we found the angles and how to memorize it. In this video, we're going to just touch on the highlights of the unit circle and then we'll get right into problem solving. All right, so if you look at my notes here, we have the basic unit circle, all right? And the unit circle is a circle with its center at the origin, and we have a radius of 1 unit. Positive angles are measured starting on the positive x-axis, this is the positive x-axis, and going counterclockwise. So when we have a positive, this is positive 90 degrees, and this would be negative 90 degrees. Right? So negative angles go clockwise. The coordinates of the unit circle are cosine, comma sine, x, comma y, cosine, comma sine. Right? So any coordinate that you find, the x part of the coordinate would be cosine and the y part is the sine. So it says without finding theta, find the cosine of theta when the sine of theta is 3/5 and theta is acute. So acute is a geometry word, meaning that it's less than 90 degrees. So we know that this angle is going to occur in the first quadrant. So let's draw our triangle. All right. And we're saying that the sine of theta is equal to 3/5. Now remember, the sine is opposite over hypotenuse. Opposite over hypotenuse. So across from theta is the opposite side, that's 3. And the hypotenuse is always across from the right angle, so that's 5. And then we just need to find the value of the adjacent side, x. So we could use the Pythagorean theorem. So x squared plus 3 squared equals 5 squared. And solve for x. So x is equal to plus or minus 4, but of course we're in the positive x-axis, we're in the first quadrant, so we know that x is equal to 4. And now we just have to find the cosine. So the cosine of theta is equal to the adjacent over the hypotenuse. Adjacent is the side next to theta. So it's going to be 4/5. All right, so pretty easy. Now, determining positive and negative values in the unit circle. So there's an acronym I like to use, all students take class. We have all students take class. And what does that mean? That means all. So it means cosine, sine, and tangent are all positive in the first quadrant. In the second quadrant, only sine is positive, so cosine and tangent are both negative. In the third quadrant, tangent is positive, and cosine and sine are negative. And in the fourth quadrant, cosine is positive, and sine and tangent are negative. In the formula booklet, I always like to note, if you go to topic 3, right, they will give you the value for tangent, what the ratio is, it's sine over cosine. And they also give you the Pythagorean identity. I like to say sine squared plus cosine squared, we are 1. All right, that's something, both of those really you should have memorized, but they are in your formula booklet. Now, here's the whole unit circle. And again, you really need to have this memorized. This will show up, of course, reference angles and using those reference angles on standardized tests. So you should have it memorized. But here I have it for you all laid out. We have all the different angles. We have all the coordinates of each angle. And remember, it's x, comma y, cosine, comma sine. All right. And I also included the tangent for each angle. And the tangent is sine over cosine. Now, since all of these are over 2, you can just ignore the denominator when you do the tangent. So for example, for pi over 6, the tangent is the sine over the cosine. So it's 1/√3. if you look at pi over 4, again, tangent is the sine over the cosine. So root 2 over root 2, that just gives you 1. So I have the cosine and sine for every reference angle here, and we also have the tangent. Like these values outside the coordinate, these all represent the tangent values. So this should be a really handy reference as we move through some of these problems. Right, so example 2 says solve 2 cosine theta minus 1 equals 0, where theta is between 0 and 2 pi. All right, so we want to solve for the cosine of theta. So we have 2 cosine theta, and I'm going to add 1 to both sides, and then I'm going to divide both sides by 2. And so this is just saying for what angle of theta is the cosine equal to 1/2. And then we just want to go back to our unit circle and we want to look for values of the cosine where it's 1/2. Now we know that the cosine is positive in the first quadrant and the fourth quadrant. So those are the only possibilities we have. And where is the cosine equal to 1/2? It's equal to 1/2 at pi over 3 and 5 pi over 3, right? It's in the first quadrant and it's in the second quadrant. So very easy. If we know our unit circle, theta is equal to pi over 3 and 5 pi over 3. All right, that's it. Moving on to part B. We want to solve for the tangent of theta. So we're going to subtract 2 from both sides. So we get 2 tangent theta equals -2. And again, we're just looking at between 0 and 2 pi, just like in part A. Divide both sides by 2. And again, we're asking ourselves, where is the tangent equal to -1 on the unit circle? All right, now, if we remember our acronym, all students take class, right? We know that the tangent is negative in the second and the fourth quadrants because the tangent is positive in the first and the third quadrants. So the tangent is -1 at 3 pi over 4, and the tangent is -1 at 7 pi over 4. And we're done with that one. All right, moving on to example 3. Now this one looks a little scary. And the first problem here is that I've got cosine and sine in one problem. And whenever that happens, you know that you're going to need to use our Pythagorean identity. Sine squared plus cosine squared. We are 1. Let's write that down. So what we want to do is we want to be able to replace cosine squared with something that just has sine squared in it. So if we solve this guy for cosine squared, then we'll be able to convert this whole equation into only the sine of theta. So let's solve for cosine squared. So now we're going to replace, and I'm just going to highlight, so we have cosine squared theta here. We're going to replace that with 1 minus sine squared theta. And you want to be really neat and careful. You want to be able to read your own writing. All right. And you don't want to skip any steps. Okay. Now we're going to distribute the -2. And let's just combine like terms here. We have -2 and +1. And at this point, we have to factor. Now, some people can look at this and they can understand how you would factor this. You may want to just rewrite it. We'll just replace sine of x with x. I'll rewrite it over here. So what we really have is 2x squared minus x minus 1. That's what we have to factor. All right, if we factor that, that looks a little easier. It's a little less intimidating. That factors to 2x plus 1, x minus 1. All right, so now we know how we would write out factoring to sine squared x minus sine x minus 1. We would just replace the x's with sine x. Now, you don't have to do the step that I did in blue if you can see it really clearly without writing it like that. That's absolutely fine. But it does, often help people to kind of read it, rewrite it, and then put it back in terms of sine x. So we essentially have what we had in example 2, but we just have 2 parts that we have to set equal to 0 here. So we have 2 sine x plus 1 equals 0. And we also have sine x minus 1 equals 0. And we're going to solve both of those for the sine of x. So we get the sine of x equals -1/2, and we get the sine of x equals 1. So for this problem, we want to go back to the unit circle, and we want to find what angles have a sine of -1/2 or 1 to solve this problem. All right, so let's go back and look at our unit circle. So on the unit circle, we know that the sine can only be negative in the 3rd and the 4th quadrant. And we're looking for values of sine that are -1/2. So the second part of the coordinate is -1/2. So we have it at 7 pi over 6, and we have it at 11 pi over 6. So that's the first part of this. The second part of this is asking us, where is the sine 1 on the unit circle? The only place on the entire unit circle where the sine is 1 is right here at pi over 2. So our other solution for this is x equals pi over 2. So we have 3 answers. We have 7 pi over 6, 11 pi over 6, and pi over 2. All right, let's try example 4. So we have to solve for the sine. So I'm just going to rewrite this. We have to undo sine on both sides. When we have to undo sine on both sides, we're going to take the inverse sine of both sides. The inverse undoes it. So we're going to take the inverse sine of this side, and we're going to take the inverse sine of the right side. So on the left side, when I take the inverse sine of 2x, I'm just left with 2x. And over here, I'm left with, well, what's the inverse sine of root 2 over 2? And so what you have to ask yourself is, this is saying, where are the angles on the right side of this? This is saying, at what angles is the sine root 2 over 2? So let's go back to the unit circle and find values of sine that are root 2 over 2. And again, the sine can only be positive in the first quadrant and the second quadrant. And the sine is root 2 over 2 at pi over 4. And the sine is root 2 over 2 at 3 pi over 4. So 2x is equal to pi over 4 and 3 pi over 4. Now we just have to solve for x. So we're going to divide 2. You could think of it as multiplying both sides by 1/2. So on the left side, we get x. Pi over 4 times 1/2 gives me pi over 8. And 3 pi over 4 times 1/2 gives me 3 pi over 8. So our final solution here is pi over 8 and 3 pi over 8. All right, with these, you're going to need a lot of practice. So thanks for watching to the end. Good luck. Have a great day.